Hello students, this is Varun. In previous video, we discussed about midpoint theorem, and now we are going to start with converse of midpoint theorem. But before that, let us recall midpoint theorem once again. According to midpoint theorem, the line segment joining midpoints of any two sides of a triangle is parallel to third side and is half of it. Like if in triangle ABC, P is midpoint of AB and Q is midpoint of AC, then line segment PQ is parallel to BC and PQ is half of BC. On the other hand, converse of midpoint theorem says that in triangle ABC, if P is midpoint of side AB and PQ is parallel to BC, then Q is also midpoint of side AC. And accordingly, we can make the statement of converse of midpoint theorem as the line segment drawn through the midpoint of one side of a triangle parallel to another side bisects third side. If we have a triangle ABC and P is midpoint of side AB and PQ is drawn parallel to BC, then we have to show that Q is midpoint of AC. So let us mention given and to prove first. So here we mention given that AP is equal to PB. It is given that AP is equal to PB and PQ is parallel to BC. This side PQ is parallel to BC, and to prove is AQ is equals to QC. Since we have to prove that Q is midpoint of AC, that is why under to prove we will write AQ equals to QC. Well students, to prove this we have to do some construction. Through point C, we will draw a line parallel to BA, and then after we will produce PQ to intersect the line which is parallel to BA. So here we mention the same that draw CL parallel to BA from point C and produce PQ to intersect CL at point R. Now students, under proof, first of all it is given that PQ is parallel to BC. Since PQ is parallel to BC, so PR is also parallel to BC, because we know that if we extend two parallel lines indefinitely in any direction, then they will never intersect and still they will remain parallel. So PR is also parallel to BC, and the reason is extended parts of parallel lines are also parallel to each other. And here we mention the reason that extended parts of parallel lines are parallel, and let this be number 1. Also from construction we have BA is parallel to CL. Since BA is parallel to CL, so BP is also parallel to CR. This is parts of parallel lines are also parallel to each other. That is, we have mentioned here that also BA is parallel to CL, so BP is also parallel to CR. Let this is number 2. Now in quadrilateral BCRP, from 1 and 2, in 1 we have proved that PR is parallel to BC, and in 2 we have proved that BP is parallel to CR. Since in quadrilateral BCRP both pair of opposite sides are parallel, so it is a parallelogram. So we mentioned the same that from 1 and 2 BCRP is a parallelogram. Now students, since BCRP is a parallelogram, so BP is equals to CR, and the reason is opposite sides of parallelogram are equal. So here we mentioned that BP is equal to CR, and let this be number 3. Now students, we have proved that BP is equal to CR, but it is given that BP is equal to AP. So here we mention that as well, BP is equal to AP. It is due to the reason that P is midpoint of AB. From 3 and 4 we can further conclude that CR is equals to AP. So we have proved that CR is equal to AP. Now if we talk about these two highlighted triangles, we can see that this angle is equal to this angle. The reason is, since BA is parallel to CL and AC is transversal, so angle 1 is equal to angle 2, alternative interior angles. AP is equal to CR, we already have proved, and measure of this angle, that this is angle 3, is equal to measure of this angle, that this is angle 4. Again they are alternative interior angles. So we can conclude that these two triangles are congruent by ASA congruency criteria. So here we mention in triangle AQP and triangle CQR, angle 1 equals to angle 2, AP equals to CR, and angle 3 equals to angle 4. So triangle AQP is congruent to triangle CQP by ASA congruency criteria. And if these two triangles are congruent, then we can write that AQ is equal to CQ by CP/CTC, and this is what we had to prove. So students, we have proved that AQ is equal to CQ, and that is how we can conclude that the line segment drawn through midpoint of one side of a triangle parallel to another side bisects third side. And the result of converse of midpoint theorem again has a lot many applications. It can be used to solve various problems. Thank you.